This high-capacity facility uses continuous production lines designed under HACCP standards to ensure hygiene and consistent quality.
Wheat flour is the main ingredient, containing gluten proteins that create elasticity in noodle texture.
Silos maintain dry, controlled conditions to prevent moisture absorption that weakens gluten structure.
Moisture below 14% prevents mold growth and ensures ideal dough hydration later.
These magnets remove metal fragments to protect both consumer safety and machine components.
RO-filtered water avoids mineral contamination that could affect dough chemistry.
Accurate ratios determine dough elasticity by controlling gluten hydration. Mechanical kneading activates gluten, forming a protein network that traps starch granules.
Ultrasonic sensors detect uneven density, adjusting mixing speed in real time. Rolling stretches gluten strands, increasing tensile strength of future noodles.
Uniform thickness ensures even cooking during steaming. AI detection identifies deviations as small as 0.1 millimeters, maintaining precision. Wavy strands increase surface area, improving frying efficiency and texture.
Vibration reduces clumping, allowing smooth steaming and frying.
Each block is standardized in mass for accurate nutritional labeling.
Automation minimizes human contact, reducing microbial contamination.
Steam at 100 degrees Celsius gelatinizes starch, transforming its structure to make noodles digestible.
Proper gelatinization strengthens noodles without making them mushy.
Rapid cooling stops residual cooking and stabilizes noodle shape.
Proper spacing ensures even heat exposure during frying.
Filtration removes carbonized particles, preventing harmful acrylamide formation.
Golden browning occurs due to the Maillard reaction between proteins and sugars.
Floating indicates moisture has evaporated, reducing weight and creating porosity.
De-oiling improves shelf life by reducing lipid oxidation. Rapid cooling prevents further oxidation and maintains crispness. Crunch level correlates with internal air pockets formed during moisture evaporation.
Low-fat noodle varieties are dried instead of fried to reach 3 to 5% moisture levels.
Uniform airflow prevents uneven drying and brittle edges.
Gradual drying avoids thermal shock that would cause cracking.
IR reflects water molecules, allowing precise moisture prediction. Environmental control prevents releasing excess fine particles or steam. Blocks that are cracked, collapsed, or bent are rejected instantly. Controlled humidity prevents reabsorption of moisture. Positive pressure airflow blocks dust and microbes from entering packaging zones.
Robotics increases precision and reduces cross-contamination.
Even minor deviations could affect cooking time and product standards.
Seasoning packs are prepared on parallel production lines to increase efficiency.
Seasoning blends contain salt, MSG, dehydrated broth, and stabilizers, all standardized by mass spectrometry.
Oils and spices undergo emulsification to maintain uniform flavor distribution.
Sterilized oil prevents microbial growth and rancidity.
Freeze drying preserves vitamins and color better than heat drying.
Consistent seasoning mass ensures predictable flavor intensity.
Accurate placement ensures proper sealing during final packaging.
Multi-layer packaging film protects against moisture, light, and oxygen.
Correct sealing temperature prevents leaks and maintains sterility. Air removal reduces oxidation and prevents puffed packages.
Laser coating is clean, durable, and avoids chemical inks.
Defective seals are detected by measuring pressure drop inside the pouches.
High-speed cameras analyze package alignment, seal integrity, and surface defects in milliseconds. Electromagnetic waves detect even tiny metallic contaminants that may have escaped earlier filtering. X-rays verify presence of seasoning sachets and detect foreign objects invisible to metal detectors.
Defects are tracked by barcode, allowing batch-level traceability under food safety regulations.
Seamless roll change prevents downtime and ensures continuous mass production.
Multi-layer films protect against oxygen, moisture, and UV, extending shelf life significantly.
Conveyor sensors prevent congestion, ensuring smooth flow throughout the packaging line.
Sorting organizes packs into precise batches for carton loading. Pneumatic suction ensures gentle handling to avoid deforming the noodle blocks.
Carton arrangement is optimized to prevent compression during transport. Folding systems maintain exact pressure to avoid carton tearing.
Hot melt adhesive bonds instantly, providing strong and durable sealing.
Barcodes allow real-time tracking through warehouse and shipping systems.
Weight verification ensures every carton contains the correct number of packs.
Robots maintain perfect alignment to optimize storage and prevent collapse.
Stretch wrapping stabilizes the load, protecting cartons from humidity and vibration.
Conveyor logistics reduce manual handling, lowering workplace injury risks. RFID tags contain batch data, expiry dates, and production line history.
Temperature stability prevents oil oxidation in long-term storage. Relative humidity is kept below 60% to prevent packaging film from absorbing moisture.
Airflow prevents condensation, which could compromise carton strength.
FIFO ensures older batches ship before newer ones.
This ensures accurate digital inventory management with zero manual errors.
Trucks are sanitized to prevent cross-contamination during product transport.
Air-suspended loading ramps minimize shock, protecting fragile noodle blocks.
Maintaining Tashin 25 degrees Celsius slows oxidation of oils inside fried noodles.
Seal numbers ensure tamper detection during long-distance delivery. Optimized routes reduce delivery time and maintain product freshness. GPS and IoT sensors provide real-time conditions of every pallet en route.
Routine sampling ensures compliance with national food safety regulations.
Digital tracking maintains full traceability from raw material to finished product.
It measures moisture precisely, ensuring levels low enough to prevent microbial growth.
The force required to break noodles indicates crispness and structural strength.
Chromatography detects flavor compound consistency and unwanted chemical residues. Correct viscosity ensures uniform distribution when added to hot water.
Tests confirm absence of harmful bacteria like Salmonella or E. coli.
Controlled temperature accelerates bacterial growth detection for faster results.
Colony counts verify sanitary manufacturing conditions.
Peroxide value and anisidine value indicate freshness and stability of frying oil.
Measuring stretch resistance reflects gluten network performance.
Color uniformity indicates consistent steaming, drying, and frying conditions.
I'm detecting a slight phenolic note, almost medicinal.
Yes, it's subtle but definitely present. The machine wouldn't catch that.
Agreed, it's impacting the overall balance.
Ideal noodles rehydrate within minutes without becoming mushy.
Stable emulsions prevent oil separation in the final bowl.
Correct pH prevents spoilage and maintains flavor balance.
Film elasticity must withstand transport without tearing.
High-temperature chambers simulate months of storage to predict shelf life. Reports compile chemical, physical, and microbiological data for regulatory compliance. Only batches passing every safety and quality test are cleared for distribution.
Monitoring PM levels prevents contamination risks and ensures the packaging zone meet cleanroom class targets.
Statistical inline sampling verifies that upstream weight control systems remain calibrated and within tolerance limits.
Helium sniff or pressure decay methods detect micro-leaks that could compromise shelf life by allowing moisture ingress. SPC identifies trends and shifts early, so process parameters can be adjusted before non-conforming product is produced. Proactive replacement of seals and thermostats reduces unscheduled downtime and keeps oil oxidation within safe limits. Modular equipment design allows rapid replacement to maintain throughput while preserving AHEY-CCP control points.
Monitoring energy intensity guides efficiency improvements and lowers the plant's carbon footprint.
Pre-treatment removes oils and solids before biological treatment, preventing sewering problems and meeting discharge limits.
CIP uses validated detergent concentrations, temperatures, and contact times to achieve microbial log reductions without manual disassembly.
Smooth, crevice-free welds minimize microbial harborage points and are essential for food-grade stainless systems.
Verifying oil temperature and residence time ensures lethal reduction of transient contaminants and consistent moisture removal.
Regular calibration against traceable standards maintains measurement accuracy critical for process control and lab comparability. Physical zoning and procedural controls prevent cross-contact with allergenic ingredients, protecting sensitive consumers. Validated changeovers include cleaning, ATP swabs, and test runs to confirm allergen absence before production resumes.
Selecting recyclable materials and designing for recyclability reduces post-consumer waste and supports circular economy goals.
On-site rapid screening allows quick rejection of contaminated lots, protecting flavor and regulatory compliance.
Mechanical integrity testing ensures packs survive stacking and transport stresses without micro tears that allow moisture ingress. Reformulation studies use sensory panels and shelf stability tests to balance health targets with consumer acceptance.
Pilot-scale runs emulate full production to predict behavior under scaled thermal, moisture, and mechanical stresses. Quarantine prevents release of product until all chemical, microbiological, and documentation checks are complete.
Digital batch reconciliation assures that every production step meets specified acceptance criteria before market release. GS1 standards and advanced shipping notices enable seamless retail receiving and inventory management.
Route optimization reduces delivery time and fuel use, preserving product quality and lowering transport emissions.
Dock-to-truck verification prevents shipment errors and maintains chain of custody records. Temperature logging during transit provides evidence that storage conditions remained within specified limits to avoid rancidity.
Continuous feedback loops drive corrective actions and product improvements via root cause analysis.
Simulated recalls test traceability, communication, and retrieval procedures to ensure rapid response in a real event.
Monitoring resource KPIs informs projects to reduce consumption and improve environmental performance.
Converting organic byproducts into renewable energy lowers disposal costs and reduces fossil fuel reliance.
Personnel hygiene and procedural training are fundamental to preventing contamination and ensuring consistent quality.
Virtual modeling allows parameter sweeps to optimize crispness, oil uptake, and throughput without disrupting production.
Monitoring MTBF focuses preventive maintenance, where it will most improve uptime and reduce costs.
Scrubbers and filters remove particulate and volatile compounds, ensuring compliance with air quality limits.
Composting returns organic matter to the soil and diverts waste from landfills, improving sustainability.
Kaizen events reduce changeover times and increase OEE and lasers.
Third-party audits validate that the facility meets ISO, FSSC 22000, or other food safety standards.
Regulatory filing ensures labeling and composition meet country-specific requirements to avoid import rejection.
OCR and vision checks prevent mislabeled shipments that could create safety risks or recalls.
Supplier audits and scorecards encourage responsible sourcing of wheat, oils, and packaging materials.
Hearing protection programs and engineering controls mitigate occupational noise exposure for worker safety.
Biological and chemical oxygen demands are key indicators of wastewater impact and treatment effectiveness.
Oils with improved peroxide and anisidine profiles extend shelf life and reduce off-flavor formation.
Periodic deep cleans eliminate biofilms and allow inspection of hidden components to prevent long-term contamination.
Retained samples permit retrospective testing if a contamination concern arises in the future.
Material science balances barrier performance against recyclability to meet both shelf life and environmental goals.
Triangle tests statistically determine whether consumers can detect differences between product versions.
Anomaly detection protects against process drift, ingredient substitution, or cyber-physical tampering.
VFDs reduce energy consumption by matching motor speed to load demand, improving overall plant efficiency.
Integrated dashboards enable data-driven decisions that balance safety, cost, and environmental impact for continuous improvement.